Hello and welcome to this short tutorial on a high-level pipeline pattern tuning plugin for Periscope tuning framework. For the purpose of this video, we will simply refer to the plugin as the pipeline plugin. In this video, I will introduce you with the basic concepts of the pipeline plugin. Afterwards, we will go through the tuning process using an image processing example. Finally, we will see some performance results. Tuning plugin for high-level parallel patterns currently supports tuning of pipeline patterns. Dynamic heterogeneous execution of pipeline patterns is supported by the framework developed within 3-year European project PEPPHER. The framework comprises high-level coordination language in the form of C or C++ pragma directives, the pipeline coordination layer that builds on multi-architectural, performance-aware components, and task-based asynchronous execution model provided by the StarPU heterogeneous runtime system. The framework exposes various tuning points for the external tuner. These may be pattern-specific, such as stage replication factors or buffer sizes for pipeline patterns. Or they can be more general, like runtime properties, such as task scheduling policies or number of execution units in use. Following animation gives a short overview of the framework. First, we start from the serial code with pragma annotations, signifying the pipeline pattern. This code is then processed with the transformation tool. The transformation tool queries the PEPPHER component repository for available component variants. Each component might have multiple implementation variants, for example, CPU and GPU implementation variants. The original code is then transformed into a representation that utilizes pipeline coordination layer that runs on top of StarPU runtime system and features Periscope-specific instrumentation. Additionally, the transformation tool generates CR file for Periscope tuning framework. We will now demonstrate the tuning process using an image processing example. The example performs a face detection over a stream of images. As the result, all detected human faces in the video will have rectangles around them. We will use PEPPHER framework to annotate face detection pipeline for parallel execution on a heterogeneous system, and let Periscope tuning framework with pipeline tuning plugin find a good execution scenario. This is a straightforward implementation of face detection using Open Computer Vision library. This while loop is using 4 components to perform face detection. Each image is loaded into memory and converted into a grayscale image. Face detection is performed over a grayscaled image and the result is written into a new file. Actual component implementations have been previously written and stored in PEPPHER component repository. The most computationally intensive component is Detect Faces, which features implementation variants for CPUs and for GPUs. To indicate that while loop is a pipeline, we simply annotate it with PPH pipeline pragma. PPH stage pragma may be used to set up stage replication factor. We use it for the most demanding stage in the pipeline. For the tuner, we can provide range for the replication factors and tell the tuning system to restrict the search space for this tuning point. We will now use transformation tool to transform this high-level annotated code into code that utilizes the pipeline coordination layer. As we can see, the SEER file has also been generated. We can see 4 tuning points. The replication factor that we specified manually via PPH stage pragma directive, and 3 runtime specific tuning points that were added automatically. This is generated parallel code that runs phase detection on top of pipeline coordination layer. Additionally, this code features PTF specific instrumentation. This command line calls periscope frontend and instructs it to execute phase detection binary. Use the SEER file that we generated and tune the example with pipeline plugin. The output produced by Periscope shows selected plugin, tuning points, corresponding ranges, and search algorithm in use. The end of the output features additional statistics with execution times and best scenario selection. Finally, the results show same video with different frames per second rates. The faster execution time translates to higher number of frames that can be processed in a second. The video on the right shows phase detection automatically tuned by the Periscope tuning framework. Thank you for watching this video. For more information on Autotune project, please visit www.autotune-project.eu.